Let's continue with our discussion of Discovered, Not Designed, by Sean McClure. Today is the 7th part of our interpretation. Let's bring this book to a close. In this last session, we will summarize several ways of using holism to create and build things, what we might call metamethods. Metamethods are very different from the techniques we learn in school or through deliberate practice. They do not begin with first principles, or follow fixed procedures to construct something step by step. Instead, they start from the outside, relying on pattern recognition and heuristics, advancing with a kind of naive, exploratory trial-and-error spirit. Visually, this resembles the alchemists of medieval European legends. Wizards hiding away in small laboratories, experimenting with alchemy. You mix mysterious liquids and powders together in a flask, stir them, maybe apply some heat, and see what happens. Perhaps nothing happens. Perhaps there's an explosion. Perhaps you end up with nothing but useless residue. But it's also possible that after a series of reactions, you produce a bit of gold, or that a genie or demon suddenly pops out of the bottle. This is how holism works. And it isn't mystical at all. It's reliable, because it is humanity's most primitive capability. When our ancestors explored nature, weren't they constantly poking here, trying there, combining unrelated things just to see what would happen? Thanks to AI, we now possess this ability once again. Metamethods are not just for leaders or artists. They are equally applicable to everyday work. The most basic principle is to cultivate a sense. Many people now use AI to write and treat its output as the final product. I think this is a misuse. Recently I saw a cartoon illustrating this phenomenon. An employee is told by a manager to write a 12-page work report. He doesn't have time to write that much, but he knows exactly what he did. There are really only 5 key points. So he lists those 5 points and asks AI to generate a 12-page report from them. The employee submits the report, but the manager doesn't have time to read something that long either. So the manager asks AI to summarize the 12 pages into 5 key points. Isn't this absurd? Why not just tell the manager the 5 points directly? Most writing tasks in the world are about getting the form right while ignoring what actually matters. AI-generated reports are merely more formal and standardized. They rarely add new, meaningful information. Decades ago, if your article had no spelling mistakes, neat formatting, and followed institutional conventions, people would say you were competent. That no longer gives you alpha today. Spelling, grammar, and formatting can all be handled automatically by computers, and AI makes this even easier. So where does your alpha come from? It lies in the real idea you want to convey. In the sense you finally discover through repeated thinking and writing. McClure puts it this way. Don't try to get the right words, try to get the right feeling. Whether your work reaches an advanced level depends first on whether you uncover a new feeling in the process. The feeling you arrive at after actually doing the work is often very different from what you had at the start. One sign that you're doing well is that you encounter surprises along the way. Feelings you didn't anticipate. Expressing that feeling is your best possible output. Of course, your initial expression may be clumsy and imprecise. But that's not a problem. You can iterate. Writing an article is like constructing a complex system. It involves self-reference and feedback loops, gradually generating self-organizing structures. Words become paragraphs, paragraphs become sections. Awkward sentences suddenly flow smoothly, much like a phase transition at the critical point of a complex system. But you might say, surely we can't just follow our feelings. That sounds utterly unstructured. Structure comes from attributes. As discussed earlier, attributes are macroscopic properties observable from the outside. Temperature, strength, or whether an alchemical flask yields gold. Attributes constrain and define a system. Your creative structure comes from deciding in advance what attributes you want. Metamethods require that whether something satisfies these attributes can only be evaluated after the fact, not designed in advance. If you try to reverse engineer the attributes into a blueprint at the outset, you fall straight into the reductionist trap. Take drug discovery as an example. You may want a drug with certain attributes. A specific color, texture, and form. Soluble in water and preferably also in lipids for better absorption. Chemically stable under light, air, and temperature changes. And most importantly, low toxicity and high efficacy against the target condition. The meta-method is to use heuristics and pattern recognition to create a rough compound prototype, iterate through trial and error, and continue until you discover a compound that satisfies all required attributes. Only then do you analyze it. Reductionism, by contrast, attempts to deduce the molecular structure from the attributes up front and design the compound from scratch. For complex objects, this is infeasible because too many intermediate pathways are unpredictable or even indescribable. This doesn't mean there is no design at all. Defining desired attributes is itself a form of design, but it is external design. McClure calls this meta-design. With meta-design, you specify the outcome and let the internal realization emerge. This is not mysterious. We do this with AI all the time. For advanced AI systems, especially those capable of reasoning and tool use, the recommended approach is to specify what you want, not how to do it, because the AI often knows better than you how to proceed. This aligns with what we previously called having a client mindset. Drug discovery with AI follows the same logic. You describe the desired properties of a compound without knowing what its molecular structure should look like, and AI searches massive datasets to identify and synthesize candidates. Even without AI, humans sometimes work this way. Consider novelists. A writer may define attributes first. I want to write a martial arts novel that gives readers a sense of exhilaration, so it needs revenge arcs and righteous justice. That's meta-design. How to realize those attributes? The writer doesn't follow a formula. Instead, they search and wait, imagining one plot after another until inspiration strikes, and a story emerges that fits the attributes. What truly works here is heuristics, pattern recognition, and feeling. In the end, it's not designed. It's discovered. McClure goes further and asks us to rethink the relationship between science and engineering. The common belief is that science discovers knowledge first, and engineers then apply it. But real technological history doesn't work that way. People say that without quantum mechanics there would be no computers. And that's true in a narrow sense. Computers rely on integrated circuits, which rely on transistors, which are semiconductors, whose principles involve quantum mechanics. But the engineers who designed early circuits didn't use quantum mechanics at all. Early computers used vacuum tubes, and even earlier inspirations came from mechanical systems. Engineering evolves according to its own logic, through practice, experience, trial, and optimization. This doesn't mean science is useless. Scientific knowledge establishes hard constraints. But engineers rarely invent by starting from scientific theory. Even Elon Musk's first principles thinking doesn't mean deriving chips from quantum mechanics. It usually means simplifying engineering constraints to reduce cost and complexity. Historically, engineering often comes first. Science follows later to explain why something works. Jet aircraft are a good example. Safe flight, mass production, and commercial operation were solved long ago. Yet turbulence around wings, combustion instability, and engine noise are still not fully understood today. You don't need complete theoretical understanding to build something that works. Many drugs were discovered first, found effective in patients, and only later studied scientifically. Large language models are the same. Engineers built them first. Scientists still don't fully understand why they work. In February 2023, Sam Altman tweeted, "Science is when it works but shouldn't, engineering is when it doesn't work but should." Science and engineering should not be treated as separate tracks. They should advance in parallel. Engineers experiment and create. Scientists summarize and extract laws. And sometimes scientific insights feed back into engineering. McClure makes an even more radical claim. Reductionist knowledge is not meant for direct use. If you study atomic physics and understand atomic properties, can you design a molecule or material directly? Of course not. There are too many layers in between. So why study atomic physics at all? McClure's answer is, for analogy. Do not treat scientific knowledge as foundational instructions. Treat it as nature's portfolio of case studies. Extract patterns, metaphors, and structures that can be analogically transferred elsewhere. For example, weak interatomic bonds allow materials to be flexible and resilient. From this case, one might infer that human collaboration should also avoid overly tight bindings. Weak ties allow adaptability. Similarly, atomic lattice structures may inspire urban planning or organizational design. Perhaps system structure matters more than individual components. Why have Geoffrey Hinton and Richard Sutton achieved such success in AI? They studied neuroscience and psychology, not to copy neurons one-to-one, but to abstract structural insights from the brain. They did not apply brain science directly. They borrowed from it, extracting transferable structures from nature's successful designs. In summary, McClure values feeling over rational calculation. He even argues that biased feelings are acceptable. Bias, after all, is perception shaped by repeated trial and error in a local environment. It often has practical value. Individual bias doesn't imply collective bias, but aggregating diverse biases can produce collective intelligence and cancel out systemic error. I think McClure is overly optimistic. Some biases don't cancel out, such as widespread economic misconceptions or populist resistance to free trade. Still, individual bias is often precious. As we've discussed before, preserving subjective local bias is what allows individuals to contribute meaningful input to collective intelligence. If all your views perfectly align with mainstream narratives, your perspective adds little value. This concludes Discovered, Not Designed. My final thought is that holism makes us more human. If Laozi or Zhuangzi had encountered McClure's ideas, they would likely have applauded, seeing reductionist workflows as a form of alienation. Today, as AI programming grows increasingly powerful, programmers are embracing vibe coding. You describe what you want, and AI autonomously generates entire websites or apps. One sentence can now create a product. Vibe coding is feeling-based coding. Perhaps our true role has always been to grasp the vibe. We end with a line from McClure's book. Perhaps humanity's greatest discovery will be its realization that progress in its best form brings us closer to where we started. That's it for today's content. Thank you for watching, and I'll see you in the next video.
If you feel there is value in this, please like, subscribe to this channel, and leave your thoughts or suggestions in the comments section. Let's grow together and read more good books.